Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. In this session we are going to see how to detect the eyes with the help of dlib and opencv on Raspberry Pi 4 Raspbian OS Bullseye 64-bit version. But before we move to our practical, friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much, and let's get started. So friends, we are going to detect the eyes with the help of dlib library and opencv. For that, you need to install a latest Raspbian OS Bullseye 64-bit version on Raspberry Pi 4. I have created a video how to install a Raspbian OS Bullseye 32-bit version on Raspberry Pi 4, but same video for installing the 64-bit version on Raspberry Pi 4. Okay, so install the latest Raspbian OS Bullseye 64-bit version on Raspberry Pi 4. Then we need here a opencv latest version, which is the 4.5.5. I have created a video how to install the latest opencv 4.5.5 on Raspbian OS Bullseye 64-bit version. Watch video and install it. Then for functioning our USB camera smoothly, we need here a TensorFlow Lite. Okay, so install TensorFlow Lite on Raspbian OS Bullseye 64-bit version. I have created that video also how to install the TensorFlow Lite. Watch video and install it. So I have already installed the opencv and TensorFlow Lite. Then I have connect the USB camera with the Raspberry Pi 4. Then you need to go inside the terminal. You need to run the command sudo raspi-config, hit enter, come to the interface option. The first one option is the legacy camera, select it, come to the yes, hit enter, and Raspberry Pi 4 will be asked you to reboot once. Okay, so you need to reboot here. So I have already enabled the camera, so I am not going to reboot here. Okay, so I have already enabled the camera. Now we need here a dlib library. As I told you, we are going to use here a dlib library for detecting the faces and detecting the landmarks of our faces. So for that, simply install the dlib. So sudo pip3 install dlib and just hit enter. I have already installed the dlib. Remember one thing, when you install a dlib first time, it will take some time. Okay, here our opencv, a TensorFlow Lite, our USB camera ready, then we have our dlib library also ready. So now what we are going to do, we need here a repository. Okay, so I am going to open the repository. Eye detection is the name of the repository. We need to clone the repository, so simply I will mention the link, click on the link and open the repository. Go to the code, copy it, minimize browser, open the terminal, and we are going to run the command sudo git clone, paste link, hit enter. It will clone our repository. Okay, clear the screen, ls, and this is what our folder, eye detection. Move to the inside the folder, cd eye detection, ls, and we have here our png image, which is the landmarks image, and we have here a text file. The name of that file is package. We need to move the file on our desktop, so sudo space mv space /home /pi and the desktop. Okay, so also we need to mention here our file name. So sudo, our file name is package. Just a minute, first we need to mention sudo mv, then our file name which we want to move, sudo mv package, then the path where we want to move on the desktop, so /home /pi desktop, hit enter. As you can see, we have successfully moved our file. Now what we want to do, we want to simply open first our text file, because inside that we have a link. So open with text editor. This is what the link, copy it, right click, copy, close the editor, open the browser, open new tab, paste link and just hit enter. This is the link basically for downloading the zip file. Okay, inside that zip file we have a .dat file, okay, which basically we need for detecting the faces, basically not faces, detecting the landmarks from our faces. Okay, so scroll down and as you can see file.zip, click on simply download and it will download the file. I have already downloaded. Okay, so remember one thing, you need to simply download this file.zip file. Okay, so I have already downloaded the file. I'm going to minimize the browser. I'm going to open file manager. Okay, and inside that downloads, as you can see, I have already downloaded the file.zip. Simply right click, extract here, and it will extract .dat file. As you can see, this is what our .dat file. If I just go to the rename, as you can see, .dat file. Okay, so we want to move this file inside /home/pi, because we are going to create our coding file, means our Python file inside /home/pi, and we need to move this file inside the same directory where we are going to create our script. So copy or cut, then go to the pi, and here simply paste it. So we successfully paste our file. Okay, so now what we want to do here, again I am going to go inside the where we clone our repository. We clone our repository inside the /home/pi. So this is what our folder, and here as you can see we have our .png file. Simply right click, image viewer, and as you can see this is what our landmarks points. Okay, so for eye detecting we need here these points. As you can see, these points, we are going to use all these points for detecting the eyes. Okay, so we are ready. I'm going to minimize this PNG image and I'm going to open our Thony editor. So programming, Thony Python IDE. Okay, so simply as you can see there is a file which basically untitled, so we need to give the name for that file. So simply click on save and give any name. I am going to mention the test.py. This is what our file name, simple. Okay, so we are ready. First we need to simply create a video capture. So import cv2, then import numpy as np, then cap is just a variable. Cap is equal to cv2 dot video capture. Then we need to mention the index number of our camera. In my case I have here only one USB camera, so 0 is the index number. Then while loop, while true, just a minute. Okay, so while true, then we need to mention rate frame is equal to cap dot read. Then we need to resize our frame. So frame is just a variable. Frame is equal to cv2 dot resize. Then mention our frame. Then width and height 640 and 480 is our width and height. Okay. Then simple cv2 dot imshow, and inside that mention the window name, which is a frame. You can mention any name, then our frame. Okay, then if cv2 dot wait key is 1, it will break the loop. Then we are going to release our cap dot release, and then cv2 dot destroy all windows. Okay, simply save the code, and simply if you run the code we will get the frame from our camera. So as you can see this is what our live frame, simple. Now simply stop the code. Okay, now we have our frame ready. Now what we want to do, we are going to simply first create the gray frame. So after the frame we need to mention a gray. This is just a variable. Gray is equal to cv2 dot cvt color, cv2 dot cvt color. Then inside that bracket we need to mention the frame, then cv2 dot color bgr2 gray, bgr2 gray, all the way capital, okay, bgr2 gray. Now if we show the gray, then we will have the gray frame, okay. So I am going to save the code, run the code. Then as you can see, right now we have our gray frame, okay. So just stop the code. Now what we are going to do, we are going to simply import our dlib library first. So mention the dlib, import dlib, that's it. Now with the help of dlib, as I told you, we are going to detect the face, also we are going to detect the landmarks. So simply we need to mention a variable here. After the cap, we are going to mention detector. Detector is a variable. Detector is basically dlib dot get. What we want to get here, we want to get the frontal face. So dlib dot get frontal, okay, frontal face detector. Detector is variable. Detector is basically what? Detector is dlib dot get frontal face detector, okay. Make like this way, that's it. Now another which we are going to use, as I told you, we need to get the shape. So predictor is variable. Predictor is equal to dlib dot shape, then mention dlib dot shape predictor, that's it. So what predictor is? Dlib dot shape predictor, okay. And inside that we need to mention that file which we move inside the home py. So open the file manager, and this is what the file. Right click, click on rename, and we need to simply copy the name, okay. So copy the name, cancel, close, and just paste that name here. Just paste it like this way, okay. And we need to make the file inside in double quote, okay. So we need to mention the file name, okay. Remember one thing, as I told you, we need to move that file in same folder where we are going to create our script. So I have created the script, the test.py, a script file inside /home/py. For that I have moved this .dat file inside same folder /home/py, okay. So we have our detector ready, we have our predictor ready. Now we are going to use these two variables for detecting the face and detecting the landmarks. So simply after the gray, first we are going to detect the faces, okay. So after the gray, we need to mention here a variable faces is equal to detector is our variable. Detector is the variable which basically our dlib dot get frontal face detector, okay. So mention the detector variable here, and we are going to pass a gray frame, the gray frame inside the detector, and it will detect the faces. Now for face in faces, now we can simply print the face. If all good, we will get the array, okay, we will get the numpy array. Simply I am going to save the code, and if I run the code, as you can see here, we will basically have here arrays, okay. So if I move like this way, these array are changing, okay. So simply I am going to save the code, stop it. Now what we are going to do, first let me change here the gray frame, okay. We need to mention here our frame, not basically the gray frame. So change the frame. Now I am going to again show you. So this is what our live frame. If I move the face, you can see here the arrays are changing, okay. So we successfully detect our face with the help of dlib. Okay, stop the code. Now what we want to do, we want to detect our eye. Okay, so if I open, just a minute, if I open the landmarks.png file and I want to make here a zoom in. Okay, zoom in, zoom in, zoom in. So as you can see, if we want to detect the eyes, we need to detect or we need to capture these points. Okay, so let's just capture the first point. As you can see, this one, the 36 point. Okay, so how to do this? Simply I'm going to minimize the image, and here after the faces, okay, here we need to mention a landmarks. Okay, because we have our predictor. So predictor is basically the shape dot predictor. Now after the for face in faces, we are going to create another variable, which is the landmark. So landmarks is equal to, we are going to use here a predictor variable, predictor. Inside that we need to mention the gray frame and we need to mention a face. Okay, now what we are going to do, we are going to create a circle on particular point. So in this case, for knowing purpose, we are going to create the circle on 36 number part. Okay, so create the circle. For that we need here a x and y. So how to do this? Simply x is equal to landmarks. Okay, x is equal to landmarks, because we have our landmarks, and landmarks is basically our predictor with a shape. Okay, so landmarks, then 36, sorry, I forgot to mention the parts. So landmarks dot part, and mention the name, mention the number which we want to show here. So we want to show here a 36 number part, or we can say 36 number point. So landmarks dot part 36 dot x. Okay, then y is equal to landmarks dot part, again same 36 dot y. Now we have our x and y coordinates. Now simply we can basically draw here a circle. So cv2 dot circle, we are going to draw the circle on our frame. So frame, then x and y coordinates, then 3 is the radius, then we are going to make the color. So color is, let's make it red, so 0 0 0 255, then the thickness, let's make a 3. So we have now a circle. Now what basically happened here, we have the circle on particular point of our eyes, which is the 36 in this case. So I'm going to save the code, and if I run the code, if you see clearly, this is the red circle, and this is what our 36 number point. Okay, if I make the image like this way, as you can see here, this is the 36 number point on our image. This is what our 36 number point. Okay, so this is how we can basically successfully detecting our facial points. Okay, so now we have our facial points. Now there is no need to create the circle. Okay, so I'm going to simply comment all these lines, comment it, and what now we are going to do, we are going to draw the line. So if I open the points again, and here what we are going to do, we are going to draw the line in between 36 and 39. This is what the horizontal line, 36 and 39, and then we are going to draw the line for a vertical. Okay, but first we are going to draw a line as a horizontal, 37 and 39. Okay, so let's just do this first. So first, after here, we are going to draw the line. For that we need the points, so let's make it first a 36 means the left one and the 39 means the right one. Okay, so left point is equal to, we need to mention the landmarks, because inside that landmarks we have all our points. So mention like this way, landmarks dot part, the 36 number dot x, then again landmarks dot part 36, and this time this is what the y. Okay, then right point, just a minute. Okay, the right point is equal to landmarks dot part, and this time the 39. Okay, I'm going to show you again. We mentioned 36 as a left point, now we need to mention this one point 39. Okay, so 39 dot x, landmarks dot part 39 dot y. That's it. We have now our left point and right point. Now we can draw the line. So make like this way, horizontal line, then is equal to cv2 dot line, then we are going to draw the line on our frame, then our left point, then right point, then we need to mention the color, so I'm going to make it green, then the thickness, let's make it 3. So horizontal line is equal to cv2 dot line frame, our left point, okay, our left point and our right point, then the color 2550 means the green and thickness is red. Now if all is good, we can see the line in between 36 and 39 point. Okay, so if I run the code, and as you can see here friends, this is what the green line, horizontal line in between 36 number point and 39. Okay, so we have now our horizontal line. Now we want to draw, as I told you, we want to draw the vertical line. Okay, we want to draw the vertical line, but here as you can see, we want to draw the line in between 3738 and 4140, means the vertical line. For that we need the point in between 37 and 38, 41 and 40. Then we can draw the line, the vertical line. So how to get the point in between 37 and 38 and in between 41 and 40? That's why we need to we are going to use here from math hypot function. The hypot function will get us a point in between 37 and 38 and in between 41 and 40. So how to do this? Simply we are going to import here our math function. Just a minute. Okay, after the dlib, we are going to make from math import hypot. Okay, from math import hypot, and then after predictor we are going to create the function def midpoint is the name of our function. Then we need here a 0.1 and 0.2. Okay, then return p1 dot x plus p2 dot x and divided by 2. Okay, then p1 dot y plus p2 dot y, then divided by 2. That's it. Okay, so just save the code first. So this is what our function, which basically get the midpoint. Okay, so midpoint from 37, 38, 41, 40. Okay, so 37, 38 is our center top and 41, 40 is our center bottom. Okay, so we are going to make like this way. We have our function ready for getting the midpoint. So after the right point, we are going to mention our center top and center bottom. So center top is equal to our function name, which is the midpoint, which we created for getting the midpoint. Okay, so midpoint, then landmarks dot part, and the first point of our top is a 37, then the 38. Okay, so we need to mention here landmarks dot part, first point 37, then landmarks dot part 38. Okay, that's it. Then center bottom is equal to, again, our function name midpoint, then landmarks dot part, the bottom, first point 41 and the second point 40. Okay, so 41, then landmarks dot part 40. That's it. Now we have our center top and center bottom. Now we can simply draw the vertical line. So just a minute. Okay, so after horizontal line, we are going to mention vertical line is equal to cv2 dot line. Then where we are going to draw? We are going to draw on our frame. So frame, then the center top, then center bottom. Okay, and then the color, we are going to make it green, 0255, then 0, 0, then thickness same 3. Okay, so if all is good, we can see two lines, a vertical line and the horizontal line. Save the code, run the code. What is the error? Oh, I got it. What is the error? Let me just stop the code. I forgot to mention here a int. Okay, so we need to mention here a integer, int, also here in function. Otherwise it will get us a float number. So we need to mention here a int. Okay, so simply save the code, and this time we will see the result. Okay, run the code. And as you can see, we have, if you see here clearly in my eyes, we have a vertical line, this one vertical, and we have a horizontal line, vertical and horizontal. So this is how you can, friends, basically detect the eyes. So in next video we are going to detect the blinking. Okay, so we will meet our next video. Till then, thank you, take care, and bye bye.